All right, cool. So welcome to the first lecture of Intro to iOS Development. We're all really happy to have you guys all here. We have a few TAs on the side, so if you have any questions at any point, feel free to just like raise your hand and one of them could come to you. Yeah, so we're gonna start with some introductions first. Just who we are, what we do, and first is Noah.
All right, hi, I'm Noah. I'm a sophomore studying CS and marine bio. Just little photos in the background. I love my dog, more fish because marine bio. I'm also really interested in graphics. So if you're interested, I would love to talk about it. A little about me and why you should like actually care about me as a teacher at all, or listen to me. Is I've been studying Swift for 4 years. I've been on AppDev for 3 semesters, working on pods like Eatery and Resell, and I've seen my fair share of Swift. So
Yeah, and I'm Justin. So I'm from Hong Kong. I like playing table tennis and chess. I like traveling a lot. I'm the current course instructor as well, along with Noah for this for iOS this semester. And it's not on here, but actually no, it is on here. I previously was working on Eevee, and right now I'm working on Volume. So you guys should all download that. All right, cool. And so here is our lovely, lovely, lovely course staff. We have 7 people in total. And the office hours and like all the the detail of like how you can contact them and stuff like that is going to be on the course textbook. You guys should have already gotten the email for that. Show of hands who hasn't gotten that email. Perfect. Cool. All right. Cool. So now we're going to go over some course logistics.
all right, so you can take this course typically with a Mac. We're also experimenting with iPads. I don't think anyone actually said that they were going to try using that, which is probably a good thing. It would be really hard. But if you wanted to, you theoretically could. Technically, you can also use some Windows computers that can run Mac OS, but for the most part, probably better to have a Mac, which kind of sucks, but that's the way it is. Hopefully you've downloaded Xcode by now. If not, you should probably do that before our first assignment because you will be using that literally for everything in this class. And if you have any issues with downloading newer versions because your computer is outdated, just let us know and we can help you out with that. But it is typically better to get newer versions because there'll be some extra complications later on. So the logistics about homework is we will assign homework once a week. Technically, you could start it on Monday, but we'll have covered everything by Wednesday, so you should probably start it by then. And it will be due the following Monday, except we're going to allow 2 slip days, so you can turn it on Wednesday. The one exception to that is this week because we have break. So the official date is Wednesday, and then you can technically turn it in on Friday. For resources, we have Ed. We will all be patrolling that, answering any questions you have. We also have a pretty extensive textbook, which has entries about the syllabus, about office hours. Every single chapter we have will have a little description about the homework, some description about what happened in lecture. And then we also have been creating a Swift guide, which is kind of like a Swift specific textbook. And it's currently under construction. Most of it's done, but we'll let you know once sections that are relevant to the current coursework are like readable. We also have a course Google Calendar. This will be posted later, so you guys can get the links.
Yeah, and when in doubt, you're like, oh, I forgot when the homework is due. All of this is going to be on the course textbook. You just go into under the projects tab, and then on the top you'll see like the due date, and everything there has already been updated. So if you're particularly studious, you can look down like to the final project if you want. They're all free. Okay.
Also, if anyone has any questions, just raise your hand. Let me know.
Oh, and also there's like a mic thing. I actually never used it, but you can raise your hand and then you can turn it. And if it comes green, you can talk and we can all hear it. That'll be pretty cool.
You can also not use that if you don't feel comfortable. But yeah, so as I said with homework, there'll also be some Kahoots in class just to kind of like get some audience participation, which will be extra credit. And then if you do especially well, you'll get extra credit. And then there'll also be extra credit on the homeworks as well. We'll also be having feedback forms because a lot of this stuff is kind of refactored from previous semesters and we just kind of want to improve in general. So that will also be extra credit. And then throughout the semester, you'll be slowly learning how to build an app from start to finish. And then at the very end, we'll have one final project, which is you'll be collaborating with members from other courses. So we also teach a backend course and design and soon, hopefully marketing and Android. And you'll be working with people from other teams to build out an entire app. and that'll be your final project. But your grade will be simply the iOS portion of that. Yeah. So just a few enrollment things. Deadline to add this course is March 23rd. Deadline to drop it is April 13th. Please make sure that you are enrolled in Student Center, CS 1998, Section 601. We should hopefully have added you to CMS. If you join the class today, you might not be in it yet. And then also, we should have sent you an email yesterday with an ed link, so hopefully you've joined.
If any of you guys aren't on CMS, you can feel free to just email like the course email, or I think it's better if you make a private ed post and then we can just add you instantly. But that I should be, everybody who received the email should also be added to the CMS.
You can also just talk to us after lecture.
That works, yeah. Okay, cool. So does anybody have any questions about the logistics? Okay, cool. So now we're going to move on to like actual content now. Just for like a quick roadmap. So in this lecture, I'm going to show you just like, basic syntax. Hopefully, most of this should be like a review of like any previous like programming language you've worked with before. But we'll try to go as slow as possible so that you really understand the basics here. And next lecture, so on Wednesday, we're going to go into more advanced features. And then like after that, you guys can attempt the homework, which will be pretty interesting. Okay.
One thing I will add is if you're coming from an untyped language like Python, it will be a little bit of a learning curve there, but it shouldn't be too hard. And our TAs in office hours are more than willing to help you with that.
Mm-hmm. Cool. So most of modern like iOS apps are built using Swift. Swift is a language that's used to build iOS apps, and it's simple, expressive, fast, and safe. So this is Swift. This is not Swift. This is how we used to build apps. You see how there's like ampersand signs. There's like special syntax for declaring the string. There's a semicolon. There's a bunch of brackets. It's ugly, right? Now we have Swift, which is really clean and really cool. So you're gonna be learning how to build iOS apps with the new language, which is really nice. Oops, sorry. And how will the Swift is the language, right? But how will you be actually building these apps? What would you be using? That's Xcode. And Xcode can not only build apps for the phone, so iOS, it can also be used for building apps for the Mac, for the watch, as well as tvOS. But of course, in this lecture, we only really have time to kind of cover iOS. But if this course really inspired you, you can feel free to venture on to more interesting challenges. Okay, cool. All right, so let's get into the demo. Oh, uh-oh. Good.
Hi, this is Justin editing. I realized that the audio during a lecture kind of broke, so I've recorded this part of the demo so it's more clear, and hopefully it's helpful when you guys are reviewing the material. Yep. So we start off the demo by kind of like looking just at the first line, what is import? And so this should be very familiar if you worked with Python before, because the syntax is exactly the same. But the idea here is that up top, you would kind of declare all like the external packages or libraries that you would want to like bring in to your current project. So you can like kind of use other people's kind of pre-built code, and you would kind of like declare them up here. All right, cool. So let's get started with constants and variables. So what are those? In Swift, we have two ways of like declaring variables. We can either use the let or we can use the var keyword. So variables that we define using the let keywords are called constants, and using the var keywords are called, those are actually variables. And the difference is basically one is immutable and one is mutable. So let's just see what happens if we try to mutate them. So over here, the net ID is declared using a let constant. So if I try changing it to something like this, Xcode won't like it. It's going to kind of shout at me, and it says cannot assign to value. Net ID is a let constant. The reason why this doesn't work is because the net ID is immutable. However, the current year is a var variable, so that can be mutated. And so if I rerun it, let me rerun it, and it's fine. Okay, cool. So now let's move on to type annotations. So notice how up here on line 8 and line 9, I never really tell Swift that netID is actually going to take on a string, and current year is actually going to take on an integer. Swift kind of just guessed it based on what I'm giving it, right? Because over here I define the variable and I instantly assign it. But let's say, for example, that I know for a fact that the variable that I'm declaring right now is going to be of a specific type. So over here, for example, on line 21, I'm defining a variable called full name. And I know for a fact that names are strings, hopefully. So how do I tell Swift that it's definitely going to be a string? That's where the type annotation comes in. So what you do is after you use the var or let, and then you give the variable a name. Right after, you can use a colon, and then you pass in the type of the variable. So it could be a string, it could be an int, it could be a UI label, which is part of UI kit that we'll be using extensively in future lectures, or it could be anything, right? And then after that, then you continue with giving it a value. And so what this effectively does is it basically tells Swift that, okay, so full name is a variable that can only take on strings. So let's say, for example, I try to change full name to Noah. And if I run that, it's fine, no error. That's because I'm changing it to something that is still a string. However, if I try changing it to something that is not a string, say for example an integer, it's going to throw me an error, right? Because Swift is strongly typed. That means after a variable takes on a type, it can no longer change its type. And kind of going back to what we did up here, over here I never really gave like net ID or current year a type. So say for example I do some mysterious variable is equal to hello. That's fine. And the reason why that's fine is because this is what we call implicit typing, where basically based on what value you're assigning to the variable, Swift kind of just guesses what type the variable is. So this line of code is actually exactly the same as doing this, but with a string. And so what that means is that even though we did not strictly put this type annotation after some mysterious variable has to be a string from now on, or like from line 27 onwards. So if I do something like this is equal to 1, that's not going to be okay, right? Because as seen from the examples before, after a variable takes on a type, it can no longer change its type. Okay, cool. So let's comment this out, and let's move on to the next section. Okay, so now let's talk about printing. So the way you print in Swift is very similar to the way you print in Python. So you use the same print keyword here, and right after the keyword, you kind of just put what you want to print. So let's use the classic hello world example, and let's run it. As you can see, it prints out hello world. And you don't have to only put a string. Like print does not only take a string, it can also take anything. And actually the type it takes is of type any. So you can print like 1, you can print, say for example, I'll give you an array of numbers like 1, 2, 3, 4. These all work. Print 1, 2, 3, 4. And actually we'll be talking about arrays later, so let's just comment this out for now. But that's not all. So there's actually a special trick with Swift called string interpolation, and it comes in really handy when you're debugging things. So say for example, you're writing a big program, and say like an XY variable takes on multiple different values throughout your iteration, and you want to figure out what these values are each iteration. So what you could do is print them out. That's a common way of fixing things. So let me just define the variables here. So var x is equal to like 1, var y is equal to like 2, and I want to print them out. So one way of doing it is kind of sticking strings together just by adding them, right? That's called string concatenation. X is string of x, and then y is plus string of y. Okay, and so let's print that out. And we see that, oh, okay, let me just add a space here and remove these two so we have a cleaner terminal output. Try one more time. Cool. So we see x is 1 and y is 2. But notice how this notation is looking kind of ugly, right? So we have like 4 string additions, and so the thing here is that the reason why I'm turning, or like basically turning the integer into a string here, is because to do string concatenation, or basically adding strings together, right, just sticking them together, they have to be strings, right? I can't just put an integer in, so I have to turn them into strings first. But there's actually a much cleaner way of doing this in Swift, and that's what we call string interpolation. And the way it works is basically you just type what you want to say, just minus the variables first. So x is something, and y is something. And over here, you just use a backslash plus parentheses, and you just drop your variable in here. And we do the same thing over here. You just drop your variable in there. And what this does, it basically takes whatever the value here is, evaluates it, so over here's 1, and sticks it in the string. And does the same for y, and sticks it in here. And so if you print them both out, we said that, oh, okay, minus the space, if I add the space here, we see that they should be absolutely identical. But the second line is just a more canonical way and also a much prettier way of printing out variables. If you're going to print out multiple variables within a string. So that's called string interpolation. Okay, cool. Next, we'll talk about arrays and loops. So first, let's talk about how we want to initialize a array. So there are two ways of doing this, and the way you do it is completely up to personal preference. The first one is basically you don't put the type annotation in the front or like before the equal sign, but you put it after. Basically what you're saying here is that I'm going to declare a var variable, and it's basically going to be equal to a int array that is initialized to be empty. That's basically what this is saying here in English. And the second way is basically, functionally they're the same, right? But the idea here is that the type annotation is now moved to be in front of the parentheses, the equal sign. So over here is we're basically using the type annotation structure that we saw before, basically saying that this lecture number 2 variable is going to have type int array, and it's going to start off as being the empty array. Okay, so which one you pick is completely up to preference, and they're functionally equivalent. Just wanted to stress that. Okay. So so there are two quirks I want to mention here. So say for example I declare lecture numbers 3, right, and I do this. So this actually won't work, and the reason why is because if I don't give it that the type up front, right, so like what the array is going to store, and I don't kind of tell what type it's going to store later on after the equals, Swift won't know what's going to be put in this array. And for now at least, the array can only store something of one type. I mean, there is an exception. If you give the type any, then they can store any type, right? But technically anything falls under any. So still, this is basically saying that an array can only store a bunch of values of one type. And so the idea here is that if you don't give it a type and you just say var some values equal to an empty array, I can basically put anything at any point in, right? And so it's not going to like that. So the takeaway here is that if you're defining an empty variable, an empty array, you must give it a type. And however, if you don't, if you're defining something that is not empty, of just 1, 2, 3, 4, for example, right, then you don't actually need to give it the type, right? So this is kind of jumping back to the implicit typing thing we talked about before, where basically if Swift can kind of guess what the type is, then Swift will do so, and you don't actually have to give it the type. So this is functionally equivalent to this, right? They'll both run and won't give you an issue. Okay, cool. And so kind of mentioned that already here, but basically the elements must match the array type we add. So say for example, I declare lecture numbers as type int array. So if I stick in 1, it's going to be fine because 1 is of type int. Actually, let me just get rid of these print statements. It's kind of annoying. So let's run that one more time. Okay, cool. So if I append 1, then it's fine. But if I try appending something that is not a integer, say 1, but in a string, then it's going to complain at me, right? For the exact same reasons as above, because it does not obey the type of the variable. Cool. Oops. And let's clear the terminal. All right. So now let's move on to loops. So I'm just going to briefly talk about the syntax for a for loop in Swift, and it should be very similar to what you've done in Python. So in Python, you do something like for I in range of say 10, right? And then you'll do colon here, and then you'll do print I, for example, right? So this is kind of the equivalent way of doing it in Swift. The syntax is still for some variable number in, but instead of using a range, you're basically kind of listing out what you're kind of what numbers that you're going to go over, or like what values should num take on. Okay, and so one small quirk here is that there are two types of like these operators. You can either do one dot dot and then less than sign, or you can do one dot dot. And the difference here is that this less than sign basically means that 1 all the way to 10, but not including 10. And this is 1 all the way to 10, but including 10. All right, and we can see the difference here if we basically just run this, and if I print them both out, we should see that this one should have lectures number 1 to 9, and this should have lectures number 1 to 10, and we can see over here. Okay, and so I guess the whole point of this is kind of to like mimic the Python syntax, where in Python, like if you have a range of like 10, this goes from like 0 all the way to 9, but not including 10, right? So this is like the similar idea here. Okay, and a few things to note, to mention that were brought up during lecture. Say for example, if you want to skip over, so like if you don't want to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but you want to do like 1, 3, 5, 7, 9, you can use a stride, right? Which basically gives, you can basically give it the start, the stop, and then the by is basically the number of like items to skip over. So in the example of 1, 3, 5, 7, 9, you would do from 1 all the way up to 9, and then the by would be 2. Okay. And another thing that was brought up during lecture was, could I do something that like 10 to 1? And so unfortunately, this operation, like this this dot dot or dot dot less than, only supports like left hand side being less than and right hand side being greater than. But that being said, there's a lot of other methods that you could use, and you can feel free to search them up. That basically lets you reverse the other way. Okay, cool. So we went over that. So now let's go over a quick demo for just like stringing together all the concepts we've talked about. And what we're going to do here is create a very small simulation of a dice roll, or specifically 3 dice rolls. So let's start with thinking what we want here. So I want to have 3 dice rolls, and we learned about loops. What we could do is for dice in 1.3, and so basically that gives me values 1 to 3 inclusive. And as I'm iterating over, I basically want to roll a dice and add the value of the dice to an array. So what I'm going to do here is I'm going to first define an array. Say it's called rolled dice counts, which is equal to an array. And remember here, right, if I'm declaring an empty array, I must give it a type. So I know that the dice rolls are going to be integers, so I'm going to give it a type int. And inside the loop body, I'm going to basically roll a dice. And so here we can use a piece of code that is kind of built into Swift, or specifically built into the int class, is int.random. And basically what it does is it gives me a random number over a specific range. So I give it a specific range of 1 to 6. And what this does is it gives me picks a number at random between 1 to 6, and that's exactly what we want here as a dice roll. And what's going on here? Oh, okay. So I need in, and then I give it 1 to 6. Okay, and hopefully this goes away. Cool. So I rolled my dice. Oh, actually, I noticed it should be called roll, because if the variable names conflict, that's not going to be good. Okay, so this is my roll. Now I want to add the roll to my array here. So I'll do this dot append, and the new element is going to be, okay, where did that go? Let's try that again. Append, and the new element is going to be my roll. Okay. Finally, just to make sure everything goes in, I'm going to print them out. Roll dice count, and let's run it and see what happens. Cool, so that works. So we see 2, 5, 1. Those are my dice rolls, and they're exactly 3, and they're numbers between 1 to 6. So it worked. Now, this simulation works, but there's still one more thing I want to talk about here. Notice how after I implemented it, Swift gave me this yellow little warning here. So I guess like a quick aside, yellow is are like warnings, and red are like errors. If it's an error, you have to fix it. Otherwise, it just doesn't run. But if it's a warning, you could technically ignore it. But usually they're like pretty helpful. So I would usually at least read them. In this case, they're telling me, well, I defined a variable called dice, but I never really used it. And so, like it's fine, right? Like you can still declare variables but not use them. But canonically, it's better if you use this underbar or this underscore to basically name the variables that we don't use. And so if someone else reads your code and they see like for this variable and blah 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 blah, they know that this variable will not be used. Okay, so this is just like clean ways of writing Swift. And if I roll again, see different numbers, this animation is working great. Now say for example, I do want to use this variable over here, so let me just copy and paste what I wrote up here. What I could do, say for example, is I want to print out which roll I rolled which values. So I'm going to actually give this a different name. So it should be fine. And then I'm going to call this roll num. And let's see if it. Cool, perfect. Okay, no errors. And not only do I want to append the rolls, I also want to print out the roll number. So I'm going to print out roll number. And over here, I'm going to use our string interpolation, right, where I kind of create this. I slide in the number I want to print, and then I just keep going, typing the string. So roll number, whatever the number is, and then I put the value here. So I do another string interpolation of the roll value. Okay, cool. Yes, and let's print that. Actually, so let me get rid of these prints here, so that I only have one thing in the terminal that comes out. And this should give me the roll number, 1, roll 2, roll 3, it gets 4 to true, and this is all the rolls. Perfect. Okay, so let's wrap up arrays with some final ways to mutate the values in an array. So not only can we add to them, we can also remove from them. And so the way we remove from an array is basically, the array number, or sorry, the array name. So lecture numbers, for example, is our array name, and then we do dot remove, and then we pass in the index of the value that we want to remove. Okay, so let me just comment these out, and let's see what's inside lecture numbers first, because I kind of forgot. Right, okay, so it's numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. And I want to stress this, but the value we pass in here is the index. And in Swift, similar to Python, arrays are 0 indexed. What that means is that this value over here, the first value, is actually indexed 0. So if I do lecture numbers.remove at 0, that removes the first value here. So if I print it out again, it should give me 2, 3, 4, 5, 6, 7, 8. Okay, cool. So what happens if I try to remove from an index that doesn't exist, right? So over here, let's get rid of these print statements again. So over here, I declare a new array called lecture numbers 3, and then it's empty, and then I try to remove from it. And that should definitely error. And the error you see over here is not a very helpful error, but if you look at the terminal, it tells you it's an index out of range. And so hopefully that kind of like hints you towards what the issue is. It basically means that you're trying to remove at an index that has not been defined yet, right? Because an empty array has like no indexes, and it starts from 0. Cool. So that's remove. Now let's talk about mutating the values in the array. So again, this is very similar to the way you kind of access values in a list in Python, and the way you change values in the list in Python. So over here, say for example, I declare a variable called, under a string array called course instructors. That's Amy and Haiying. Those are the 2 instructors from last semester. And I print them out. So we see Amy and Haiying here. And I want to change them. So this semester, Noah and I are teaching. So at index 0, I put me. At index 1, I put Noah. And if I print them out again, we see that the values in there have changed. Okay? Cool. But let's say, for example, what if I try to mutate an index that does not exist, right? Similar to over here, if I try to remove something at an index that does not exist, what will happen? Right, very similar error. Again, index out of range. Okay, cool. And just one final point, right? Remember, again, that the index is 0 indexed. So even though there are 2 values in there, the final index is actually 1 and not 2. Okay, cool. And finally, we talked about append already, but basically append is the way you'd add values into an array by sticking them at the very, very end. Okay. All right, so now let's move on to functions. I'm going to cover the basics of the very, very basics of functions, but in the next lecture, Noah is going to show you more interesting ways of defining them and I guess more advanced things you can do with them. So this lecture is going to be the basics, and this is one way of defining a function. So we use the func keyword, you give it the name of the function, and then over here you would define its parameters, and then at the end, sorry, not at the end, but sorry, within the body of the function, you kind of do the thing, right? So yes, so if I run the code up to here, up to this point, nothing will actually print, right? Even though print is in here, that's because this is wrapped in a function. And so even though if I were to just have print outside, it would run. Since this is wrapped in the function, everything inside the function doesn't actually get evaluated until I call the function. So if I call print something now, and then I rerun it, we'll actually print something. Okay. And so moving on with the notions of like typing, right? Similar to how we typed variables up top. Remember if we call the netID example of like string, and then I do my netID, right? You can similarly give the parameters of the function a type. So over here, I define an add function called add, and I give it a parameter of a and b, and I say that they're both of type int. Right, so this is a very familiar notation of, a very familiar type annotation. But you can also give, and in fact you also have to give, the return type of a function. So over here the function is add, and the way you define the return type of the function is by adding an arrow after the parameter and then defining the return type. So over here, basically this is saying that I have a, which is an int, b, which is an int, and my add function would also return an int. Okay? So notice how up here I don't actually give you a return type. If I don't specify the return type, right, that's basically saying that the function doesn't return anything, or it's of type void. So it's called void. Okay? So let's just run through these examples here. I had add 2, 3, add 3, 4, right? So I defined it as basically adding 2 and 3, adding 3 and 4, and if I print them out, you see, it's 5. Right, because 2 plus 3 is 5. Yes, and sorry, this example is basically showing you how you would store the return values of a function into a variable. Right, again, this should be very, very familiar if you've worked with Python or any other programming language when you kind of work with storing the return value of a function into a variable, right? So we would evaluate the right-hand side, whatever this value evaluates to, or like whatever the function returns. Say this returns to 5, right? And then you assign, or basically you assign the value 5 to this variable over here, and then that variable now stores this value. Okay, cool. Hopefully that should be reviewed. All right, so now let's move on to optionals. Optionals is a very core part of Swift, and it's really important when you're like storing values of something you don't know just yet, right? That's a common example. And a good way to think about it is kind of like a box, right? So the box stores some value, but you don't know if it stores like something until you open it, right? So that's a way of thinking about optionals. Another example is, say for example, I ask you to create a variable that basically stores the Boolean value of whether I like chocolate or not, right? So I could like chocolate, I could not, but chances are you don't know, right? So say I'm creating the variable var do I like chocolate. It's going to be of type Boolean, right? Because it's either a true or a false thing, but you don't actually know until, say for example, you ask me, right? So it could take on the value of true, it could take on the value of false, but it could also just be like, you don't know. And so that's where optionals come in. And so the way you define an optional, similar to like all the type annotation things we've been learning, we've been talking about previously. So you still define you still put the type annotation the same way, but at the end of the type you put a question mark, and that's basically saying it takes on the values of whatever Boolean is, but can also take on the additional value of nil. And that's kind of like representing the I don't know, or like I don't know just yet type of value. Okay. So let's have a look at a quick example here. Here we have two strings being defined. One is an optional, one is not an optional. So if I uncomment both these lines, you can see the difference between a optional and non-optional string. So if I run this over here, this throws an error because this string is not an optional, it's just a normal string. So it can't take on this value of a nil. But if I declare it like so, as you see, as an optional, that means it could be a string, but it could also not be, right? It could be like nothing. I don't know just yet. That's the nil value. And so I could have it be a string, so the hello world string. Let's give it a second to update. Cool, right? It could be the string. It could also be nil. So if I run this, it's also fine. I think there's a stray print statement. Yeah, okay, let's get rid of this for now. Okay, and then if I run this, and it works. Okay, cool. So going back to the analogy of like a box, right? So right now this optional string is like a box, right? It could contain a string because I'm telling you that is a string optional, right? Or it could contain nothing. In that case, it would be nil. So how do we check? That's what we call unwrapping the optional. So a first attempt would be just to check directly what's stored in this optional, right? So you know how I talked about how an optional string could either be a string or nothing, or basically be the value nil. So if I check if the value is not nil, right? Remember, if this returns true, that means optional string is not nil, then I would execute this part and then I would print out the value. So that's a good attempt, but this doesn't actually work. You see how it still prints like whatever the thing is, but still wrapped in an optional, right? Because we didn't actually take out the value within the optional. We're kind of just like trying to cheat our way around it. So this is not a good idea. It doesn't actually work. So what we actually have to do is the following. So we have three ways of doing it, and I'm going to introduce them one by one. The first way is using an if let. So here's the syntax of an if let. You do if let, and then you do a variable name, and you assign that to basically being your optional string. Okay? So what are we doing here? The idea of doing an if let is that if the optional string actually stores a string, then whatever that value is assigned to this variable here, and then we execute the function in here. Okay? If the optional string stores a nil, then we don't execute what's in here, and we kind of, like you could also add an else clause here, and then else, then you do like print sad. Right? So let me just repeat that one more time, right? If let basically is saying if the optional string actually stores a string, then assign that string to unwrapped string, right? So basically over here, we're opening the box, we found the string, we take the string and we assign it to unwrapped string. And then in here, we can work with unwrapped string as if it's a string. So this unwrapped string is no longer an optional, it's actually a string. Otherwise, right, that means that the optional string is actually an empty box. I open it, I see it's empty, and then I deal with that case. Okay, so if I run this code here, notice how over here I assign optional string to be so basically I'm like putting the string hello world into the box. So it must execute this clause, right? Because I know that optional string actually stores a string now. So when I unwrap it, I assign hello world to be the unwrapped string, and then I print it out. And so we can see down here, the value in the optional string is hello world. And if I change this to nil, optional string is equal to nil, and then I run this. Oh, oops. Oh, sorry, optional string. We see print sad, right? Because it's now nil, therefore the optional string was empty. That means I run the else clause and I run whatever is in here. Okay, cool. Okay, so that's if let. And just as a follow-up, you're not restricted to just one, right? Say I have an optional string 1 and an optional string 2, I can kind of put them both together, right? And so keep in mind, this only runs if both these values store a non-nil value, right? So if both optional 1 and optional 2 both have a value, right? So over here, optional 1 is some string, optional 2 is a int optional, right, of 4, and I unwrap them with an iflet and I print them out, right? Okay, so let me just get rid of these print statements for now. So we have a clean terminal. Let's do it one more time. Right, so we see some string, we see 4. But if I change just one of them to a nil, then we see nothing, right? Because even though some string was actually a string optional that contained a string, optional 2, an int optional, does not contain a string. Sorry, does not contain an int. It contains nil. Therefore, we don't actually execute it here, right? Therefore, we just kind of move on. And if I had an else block here, then it will run the else block. Okay? Cool. All right, so that's our first option. Our second option is a guardlet. So a way to think about guardlets is they're kind of like the opposite of an iflet. So for iflet, we only execute this block if both the optionals, or like however many optionals I have here, all store an actual value, so a non-nil value, and then I assign whatever the value actually stores, so like opening the box and assigning the values to these variables, and then I use them within the block here. Guardlet, however, only runs this immediate block, right? It's actually an else clause, by the way, but it only runs this immediate block if the optional stores nil, right? That's like the exact opposite. And the whole purpose is that basically if you declare, if you notice immediately that the optional doesn't actually store some value, then you kind of like short circuit, right? You like return something, say, sorry, your optional is nil, or like missing value, something like that, right? In an actual program, and then you like probably rerun some other time, right? Okay, so one important thing to notice here is that the variables here are only like accessible within the block, within the iflet block, right? So say for example outside here, so outside the iflet block, I try to access unwrapped 1. Notice how it's like, even as I'm typing it, there's no autofill, right? And if I just put it here, it's going to be like, well, cannot find this within the scope. So we're going to talk more about scoping in the next lecture. But for now, what you can think about is basically, these two variables, or however many variables I define within iflet, it's only accessible within the block. Outside the block, they're gone. Okay. Guardlet, however, has the variables live outside the block, right? Because you kind of only go within this block if the optional stores nil. In that case, you kind of like short circuit or whatever, right? But after you kind of like after you do this checking and you move on past the block, that means that the optional string actually stores value, and you assign that value, like very similar to iflet again, to the variable name here, and you can continue executing and you'll have access to this variable. So if I try writing unwrapped string, see it auto completes, and if I just execute this, actually let me just print this, right? It's fine, right? Like there's no error or anything. Okay. So let's see a few concrete examples of using guardlet. So notice how this is in a function, just to kind of showcase the kind of short-circuiting behavior of using a guardlet. That's like a more common way of why we would use guardlet. So over here, I'm trying to unwrap this optional string that's nil, right? So what we would expect is that we would kind of run into this block, right? Because remember, in guardlet, we execute this else block if the optional is nil. So if I run this, we should see that, okay, so I'm gonna get rid of the, actually, so let me just clear this terminal so I can run it one more time and get a clean output. There we go, cool, okay. So I executed this line, or like from the top all the way up to this line, and it returns, guardlet returns out a function, and exactly what we expect, right? Because it executes this line. Now let's comment this out, and let's try the second example. So now I'm actually giving it a string. So over here, this optional would evaluate, or basically when I'm unwrapping the optional, it actually stores a string. So I don't run this else block, and I keep going. So I continue executing down here. And if there's more code, I just keep going, okay? And so over here, I'm printing out whatever it's being unwrapped using my string interpolation. So if I run this, I should expect to see, now I can use my unwrapped, this should be a string, unwrapped string, which is of value hello world. Okay, cool. So now let's move on to our final option of Nil Coalescing. With Python, there's this idea of short circuiting. So if I have, say for example, x is equal to 1 or 0, actually no, 1 or 1 divided by 0. Since this evaluates to true, then I would short circuit, and so it's complaining because I'm not actually writing Swift, but let's just bear with that for now. Since this evaluates to true, then I won't continue executing, right? Because of like if it's true or false, it's still true. So I can just ignore this. And so this won't, if you type this in Python, this won't actually throw an error of like 0 division because I never really evaluated this, right? So this is a very similar concept here. Basically by kind of like chaining them together with this this operation here, it's basically saying, right, if this optional string contains a value, then just give me the value and forget about what's over here, right? However, if this optional string is nil, then give me this optional value, right? That's basically the purpose of this operation here. And if I print this here, so over here, there's like the optional string actually has a value. So, what do we expect here, right? This optional string actually has a value, means we ignore this, okay? So we print this out, and we should see hello world. Perfect. Now, similarly, if this is nil, right, then when we evaluate this, this is nil. So we move on, right, and we keep we give the default value that we have here, and when we print it out, it says, well, looks like the box is empty. Okay. And this is actually really handy when you have multiple optionals. So say for example over here I have A, which is a nil, B, which is also a string. So just to reiterate, all these are all string optionals. And so if A and B are both nil, but C is nil, but the string of nil, right? And I were to chain them all together, and I assign whatever this evaluates to be str. So I guess I encourage you guys to pause the video and kind of guess what will be printed out here. Okay, I'm going to be resuming. So if I actually run this, this will print nil, but the nil that it's printing is actually this string nil, right? So if I were to change this to hello world and were to run it one more time, it will return hello world, right? Because this is nil, I keep going. This is nil, I keep going. This is not nil. This actually is a string. So I don't give the default value, and I just return whatever the string is. And so that's why when I print it out, it will be hello world. Okay, cool. So I know that I said that was the last option, but we actually do have one more option of force unwrapping. And this is actually a strongly unencouraged way of dealing with optionals. The main reason being that this is extremely unsafe. So what you're saying here is that I'm 110% sure that whatever this optional is storing is not nil. So you're basically saying that I'm like very, very sure that this box is not empty. If you're right, that's great, right? You just take the value out directly and you can keep working with it. But if you're wrong, then your entire program crashes and you get these very obscure errors, and it's basically not very fun. So let's show you a quick, I'm going to show you a quick example here. So I'm just going to call this string, which is I'm going to call this variable a string. Sorry, one more time. This variable here is of type string optional, and I give it a value. Basically, I'm saying I'm putting this hello world string into the box. And now I'm going to unwrap it. I'm going to unwrap it using the force unwrap symbol, which is basically this escalation mark, or it's called like the bang operator, right? Where you basically put the escalation mark right after the optional, right? So this is force unwrapping, and I print it. And it's fine, right? Because it actually stores hello world. Let me just get rid of this print here. So it's it only has this section, right? It's fine, right? Because it actually has the string value inside the box. However, if it does not store a string, so if it has a nil, and I try to force unwrap it, boom, right? It doesn't work. And yeah, it just crashes, and it's very unsafe because, you know, say you're like midway of displaying some data and it just crashes and your entire app crashes, and the user, you know, doesn't really get feedback of what's going on, and it's just an entire nightmare. Okay, so I guess the takeaway is that you should only really use force unwrapping if you're very, very certain that the optional is not nil, right? Say for example, you literally just put a value in beforehand and then you try to unwrap it, then yeah, you can be sure, right? But you know, whenever in doubt, try not to use the force unwrapping. Okay, cool. So that's the end of the demo. Hopefully that made things more clear. And yeah, I guess see y'all in the lecture on Wednesday.